Hey everyone, my name is Kenny Kirby, and today I'm going to be talking about contact metamorphism. But first off, I just wanted to tell everyone good luck on their final exams, and we had a great semester together, and let's just keep on pushing through. Now, to start, we're going to have an introduction to contact metamorphism. But before that, we're just going to recap on what metamorphism actually is, which is the change in the composition or structure of a rock or a mineral due to pressure, heat, or sometimes chemically active fluids. Now, contact metamorphism is a kind of metamorphism, but it's a type of metamorphism that only occurs as a result to heat. Now, this is different because there's no pressure or other circumstances that are necessary to enact contact metamorphism. And this is interesting because contact metamorphism can occur near the crust in low pressure environments, unlike regional metamorphism. Here we have, how does contact metamorphism happen? And you might be asking yourself the question, if heat and pressure are generally found very far under the ground, how does a rock change due to heat near the surface? Because wouldn't heat normally be found towards the center of the earth? Now, the answer is magma that has moved into the upper part of the crust. As the magma rises, the rock near is subjected to lowered pressures and higher temperatures. So, like I just said, we can see here as it gets deeper and deeper underground, we can see it's roughly 25 kilometers in this picture here. As we get deeper and deeper towards the center of the earth, it gets hotter, and there's more regional metamorphism occurring because there's pressure and heat on much of the rock. But here we can see a contact metamorphic areole, which I'll talk about a little bit later on, but we see this large magma pocket that's heating rock that's near the crust, and that's causing contact metamorphism to happen. Now back to contact metamorphism areoles, we have first off, the zone of contact metamorphism around an intrusion is very small when compared with the amount of metamorphic rock created by regional metamorphism, which is, as we saw before, metamorphism on a larger scale, acting on rocks using pressure and heat. Now, with this being said, the amount of metamorphic rock around a magma body, also known as an areole, varies, with the size of the chamber and the kind of rock being two factors for differences in the size and the amount of metamorphic rock that was created. So here we can see at the bottom, while some areoles are just a few centimeters around small dikes and sills, others can end up being several tens of meters around a large stock. Lastly, here we have a few examples of contact metamorphism where we can see that some of the rocks that undergo contact metamorphism include marble, which comes from limestone, we have quartzite, which comes from quartz sandstone, and we have hornfels from shale, which are all rocks that we've seen in our labs previously. We just have our works cited, which are these two sources, and I just want to thank you guys for listening in, and everyone have a great rest of the semester. Bye.